So, hi everyone, welcome to CSE Engineering. So, this today I am going to discuss a problem on information retrieval and extraction, right? So, this problem is basically for the TF IDF model. Although uh, this problem set contains many other models, but as of this video is concerned, I'll just discuss this model, right? So this will be a practical video, and the prerequisite would be uh, just basic knowledge about IRE if it is at all needed, right? So let me just place the question. So here is the question. We can see that the first one, write the expression of the TF IDF model for text finding. The following is document versus frequency term table is given. So what is given here? The term frequency table is given, right? It is very important to look into what is given. Sometimes it might be weighted frequency table, right? Sometimes it might be IDF table, right? So we need to consider that what table is given. So as of now we can see like it is term frequency table. So we will calculate the TF IDF for T3 T4. So if we just go into the question, so it says TF IDF for D3 D4, right? So for that, what we need to calculate? We need to calculate first TF of D3 D4 and multiplied IDF of D3 D4. Now, what is this D3 D4? This means we need to calculate TF IDF for term T4 in document D3, right? So this is what we need to calculate, and for that we need to calculate these two elements as well. Now the first element, TF of D3 D4, what is this? This is nothing but turn frequency of T4 in D3. Now you might say like, so this is already given, I think, that turn 4 in T3 is 2, right? Is 2. So we might say like 2 is the term frequency for T4 in T3, but keeping in mind that this is a small example and in the real world there might be like thousands of documents with like lakhs of terms, and in that case just the mere frequency, and even if you consider calculating all those frequency for each term in each of the documents is tiresome. So what we do is we use a normalization method for calculating the term frequency, which is called Cornell Smart method. So I'll just write the expression first and explain it to you. So what we'll do is we'll just use 1 plus log base 2, 1 plus log base 2 frequency of T4 in T3 document, right? We'll just use this. And what is this frequency? This is nothing but the frequencies given in the table, right? So we just need to plug in those values here and we'll be able to find the TF IDF value. So if we just use this 1 plus log base 2, 1 plus log base 2, and here if we just see what's the value is 2. So the value here will be 2, right? Further solving 1 plus log base 2, 1 plus 1. Why 1 plus 1? Because log of a base a is 1 from basic maths. Now we have this, now 1 plus log of 2, 2. Okay, so what it will be? 1 plus 1, that is 2. So the TF IDF for T3 T4 is 2 after normalization. Now since this is a small example, so we are able to see like the calculated value 2 is same as the value given in the table. But in bigger example where the document size is large or it varies across the documents, like the first document may be of 100 words, the second document may be of 1000 words, and so on. So now we'll calculate the IDF for this. IDF of TF of T3 T4. So what is the formula for that? So the formula for calculating this is log base 2 1 plus mod of d by. Now what does this all mean? So if we see, mod of d is the number of documents in the repository. Now what is repository? Repository is the place where all docs are kept. It's like a virtual library. Okay, so this is mod of d, and what is mod of dt? It is the number of docs where term t appears, right? So this is mod of dt. So if we just calculate 1 log of base 2 1 plus, so here there are 1 2 3 4 5 documents, and number of documents in which term T4 appears 1 2 3 4 5 documents are there where it appears. So accordingly the total documents is 5, and 5 documents are those where T4 appears. Now we'll just use the calculator for this calculation, that is log of base 2 6 by 5. Now I've heard that most of the students, like, they don't know how to calculate log base 2 with calculators like Casio, FX, 82, MS, or etc. any other similar calculator, scientific calculator. So I'll just brief you about the calculation, how we can like find log base anything, any number. As of this example is concerned, we'll just take log base 2. So we'll just calculate log, which is there in the calculator buttons log, and then we'll input 6 by 5, right? And then 6 6 divided by 5, right? I want you to do this along with me so that you are comfortable with this, and then I'll just divide this with log of 2. Okay, so if we see that the value is coming approximately about 0.263, let me check if I'm not wrong. Log of 6 divided by 5 and divided by log is 2. So this is coming like 0.263, right? So after this, what we'll do is just place this value here. So I feel now you are able to calculate, because in the calculator there is only two log bases, like log base 10 and log base e, which is also called as log, that is ln, right? So there are two types, but like as of now we needed log base 2, so we just divided this with log 2, right? So okay, now we have found IDF for D3 T4 and TF for D3 T4, and now I just want you to tell, like for those who don't know what this means, this is called term frequency. And this one here is called inverse document frequency. I'll just write it, inverse document frequency, right? So these are the two additional terms which we wanted to calculate in order to calculate TF IDF, which is actually nothing but like the multiplication of these two, right? So now we'll just multiply this thing. So TF IDF of D3 T4 is nothing but 2 into 0.263, which comes out to be 0. Just check, 2 times 0.263, so it comes out to be, right? So this is our answer. Okay, so I hope you were able to understand the calculation behind calculating TF IDF for a particular term in a given document, and I just want you to practice another example, which is TF IDF of D2 T5. You just need to do the exact same thing as we've done, although I will discuss it in the upcoming video, but as of your practice, I just want you to try this. Okay, just try this and comment me what answer you get. Okay, so as of now, that's it, and I'll see you in the next video.